Hi, welcome to my honours project. The objective of this project is to research the viability of using a compact, low-powered radar in place of a colour sensor to detect and identify the type of fruit by examining its shape from multiple angles. The radar used for this project is Akenea's XM112 low-powered millimeter wave radar. The best method to move radar around a fruit while aimed towards the fruit was decided to be by using an arc-like path. I designed an arc in SolidWorks with an internal spur gear indent to house a gear that could be, in the future, used to motorize the movement around the arc. Rails were added around the arc and a gear clip made to mount the radar such that it would be facing the center of the arc at all times. Finally, stands were created to allow the arc to stand upright above any fruit. Due to the limitations of the 3D printing volume provided by the university, the arc had to be printed in 3 segments with slots to connect each piece. Ideally, this would be printed as one part to prevent any catching on the connection locations from the gear clip, as gluing pieces has its own limitations. Once the radar was flashed using Bossa and set up using Akenea's Python Exploration Master, the accuracy of the radar could be tested. The gear clip housing the radar was moved to 5 different locations along the arc, negative 45 degrees through positive 45 degrees from the center respectively, and an envelope detector was run. The target was a spherical ball placed in the center of the arc, and each location was tested 5 times, alongside a ruler used to find the physical distance between the radar and the ball. The results were tabulated with the percent difference between the sensed distance and physical distance were calculated, and had found that a lot of calibration is required in the future. Another similar test that was run was by using a similar method, but by also incorporating the time domain and moving the radar at a hand-steady pace around the arc from positive 45 degrees to negative 45 degrees, where the data could be saved as an NPZ file. The example video shows the movement around the arc and the data results from the Akenea's Python Exploration Master GUI. The Python command prompt was used to convert the NPZ files to text files. These will be used in the future to graph the data in MATLAB, where similar tests can be performed over different shaped objects, and the graphs can be compared to identify the different shapes. Thank you for watching.